Hello and welcome to this Scientific Principles video with Elec Training. This video is on the subject of power. Power, well, we'll talk about it in general terms first and then we'll apply it to electricity. So what do we mean by power? Well, a definition of power is it is the rate of doing work or the rate of expending energy. Think about two sprinters that run the 100 meters. One sprinter can run that distance in 15 seconds and the other sprinter can run that distance in 10 seconds. So they've both done the same amount of work, they've both covered 100 meters, but the sprinter who can run it in 10 seconds has done that work at a faster rate. That's what power means, it's the rate of doing that work or the rate of expending energy. And just as that's true generally, it's true in electrical circuits. So electrical power is the rate of doing electrical work or of the expenditure of electrical energy. And power is measured in watts. That means the SI unit of power is the watt. You'll see I've put a triangle there and it looks rather similar to the Ohm's law triangle, but it's not got exactly the same letters in it. And we're going to explain that in terms of the power formula now. So we could call that the power triangle. So power is equal to voltage times current. So we would write that in a formula as P equals VI. And having the triangle is quite useful because just like Ohm's law, this power formula is in the same configuration, the same shape. You've got one thing on one side of the equal sign, which is power, and that's equal to two things that are multiplied together on the other side, the voltage and the current. So that's the same as the Ohm's law formula in terms of its configuration, its shape. You've got voltage equals current times resistance. So because it's in the same shape, we can produce a triangle in order to help us to carry out the transposition of the formulae. So the P would go at the top of the triangle and then the V and the I underneath, and then we can transpose the formula quite easily. If we want to find P, cover the P equals V times I. If we want to find I, cover the I and P over V, I equals P over V. If we want to find V, cover the V and V equals P over I. So there we are, that's the power formula and using the power triangle. But notice I've written down the bottom there that it's DC only. DC stands for direct current. So far in the electrical science unit, we've only really looked at circuits that are direct current circuits, DC circuits. These are usually circuits that have a battery as the source of electromotive force, and the current can only flow in one direction, which is negative to positive, but it's always one direction, it doesn't change. That's direct current. The other type of current is alternating current, or AC for short. And alternating current does change direction and it has various quantities and features that we're going to learn about in much more detail in future videos. But just at this stage, it's important to understand that this formula doesn't really hold true in the same way in an AC circuit. It's only true in a DC circuit. So P equals VI, or you could say the V and the I the other way around. That's how I learnt it, was P equals IV. Because if two things are multiplied together, it doesn't matter which way round you write them, it's the same result. So P equals VI or P equals IV, you may hear it expressed that way as well. Now would be a good time to remind ourselves of the formulae that we've learnt so far on the electrical science unit. We don't want to leave them all to the end because there's a lot of formulae and then it will be much more difficult for you to remember them for your exam. So we need to make sure we memorise them as we go along. So can you remember what formulae we've learnt so far? Well, one of the first ones was this, Q equals IT, and that stands for electrical charge is equal to the current times the time. And then we learnt V equals IR, and this is the Ohm's law formula, voltage equals current times resistance. And now we've just learnt the power formula, P equals VI, so power equals voltage times current. And in each case, because the configuration of the formula is the same, i.e. one thing on one side equals and two things multiplied together on the other side, means that we can use a triangle to help us transpose them. So if we were using the Q equals IT formula, you write Q at the top of the triangle and the I and the T underneath, and then by covering the thing that you want to be the subject, you can easily see what should be on the other side of the equals sign. And we've done that with Ohm's law, but you can do it with all three of these formulae. Unfortunately, there are plenty of formulae that we'll learn that are not in this same configuration, so you can't use the triangle, but at least for these ones it does help. So where you have a formula where you can't use the triangle, we'll be using the same principle of transposition that I have shown you previously, and I'm just going to demonstrate again with the power formula. Supposing we want I to be the subject, we want to find the current. That means that we would like to move the V away from the I to get I on its own as the subject. So if we move the V over the other side, the equals sign, it takes on the opposite function. So currently on the right hand side there, it's this side times V. If we move the V over the other side, it will be that side divided by V. So what we end up with, I'll just write it out sort of in reverse really, but we've got the I staying where it is, we've got the P staying where it is, and we're moving the V from the right to the left, so it goes from the top to the bottom. So it goes from being multiplied by V to divide by V. And that's the same process with any formula. You can move things around from one side to the equal sign as long as it changes to the opposite function. And there's probably one other formula I think that we've learnt, and that was the formula for the resistance in a parallel circuit, and that is 1 over RT equals 1 over R1 plus 1 over R2 plus 1 over R3, and potentially however many other resistors in parallel there are, you just keep adding the reciprocals and so on. So that's the reciprocal formula for calculating the total resistance in a parallel circuit. So there's a number of formulae there, and again I do encourage you to keep working on memorizing and practicing those. It really will help you as we move forward. So for now, thank you very much for listening, and in the next session we will look again at the subject of power, and unfortunately there are even more formulae regarding power that you're going to need to know. So until then, goodbye.